Okay, chapter 15, general properties of the autonomic nervous system. The autonomic nervous system is the part of the nervous system that is going to help us control many things which we don't have that much control over them. For example, visceral reflexes. It's like in the case of high blood pressure. When you have high blood pressure, voluntarily or consciously, you don't reduce your blood pressure, right? That is done using reflexes controlled by the autonomic nervous system. As you can see here, an increase in blood pressure is captured by the receptors you have in the blood vessel. That information is sent to your brainstem, and from there, the heart rate is reduced in order to reduce the blood pressure. So that's an example of a visceral reflex. So if we keep scrolling down, divisions of the autonomic nervous system, there are two main divisions. One of them is the sympathetic nervous system, and the other one is the parasympathetic nervous system. Right here you can see parasympathetic and sympathetic nervous system. If we scroll down, we said autonomic output pathways. And here they are comparing the autonomic nervous system with the somatic nervous system. The somatic nervous system, you just have one nerve that is going to help you control your muscles. In the case of the autonomic nervous system, there are actually two nerves. You have the preganglionic fiber and the postganglionic fiber. Right here, this is a ganglion where the preganglionic fiber and the postganglionic fiber are going to the synapse. Okay, so let's keep scrolling down, and that's about it. Okay, the next topic in this chapter is anatomy of the autonomic nervous system. We said we have two divisions. The first one is the sympathetic division. You scroll down, you can see this figure right here, and some characteristics that you're going to see is the sympathetic starts right here in your thorax, in the lumbar area. In the top and the very bottom, they are not occupied by the sympathetic. So since we have two divisions, sympathetic and parasympathetic, the sympathetic is going to be basically thoracic, and the parasympathetic, you will see that, is going to be basically on the top, cranial, and sacral right here at the bottom. Now, if you look right here at the thoracic area, you're going to see two fibers because we said that we have a synapse right here in the ganglion. The preganglionic, in this case, is green, and the postganglionic, in this case, is red. The preganglionic is short. The green one is short. If you compare that with the red, that's very important because there's an anatomical difference when comparing sympathetic with parasympathetic. So then the preganglionic is short and the postganglionic is long. But you will see here that the postganglionic, you see fibers on the top, fibers in the middle, fibers at the bottom, because the postganglionic can actually get three different routes. It can go to the top, it can go straight to the abdomen, or right here to the bottom. So you scroll down. Right here you have the spinal cord. This is preganglionic in green, and here you can see the three pathways that it can take. Remember I showed you that? To the top, for example, to the iris and the salivary glands. Straight goes to your abdomen, to the sweat glands, for example, the piloerector muscle in your abdomen, and goes down, for example, to your liver and your spleen. That is the sympathetic. If you scroll down, in here you have the three numbers, 1, 2, 3, again, because of the three different ways that it can go. Right here you have the set of nerves that is part of the solar plexus. Within the autonomic nervous system, in the abdomen, right here, you're going to have a set of nerves that they're going to radiate from the middle, and they're going to be also wrap around the aorta. This is going to be the solar plexus. So if you scroll down, adrenal glands, it got to do with the solar plexus, that's why it's there. Parasympathetic division. So let's take a look at this. Remember the sympathetic was thoracic? Take a look at the parasympathetic. Parasympathetic is at the top and at the very bottom, cranial and lumbar. Another thing that you can look at is, for example, remember we said in the sympathetic, the green was short and the red was long? Well, in this case of the parasympathetic, the green one is long, the preganglionic is long, and the postganglionic is short. Okay, and you can see this again, parasympathetic is going to be at the very top, cranial, and at the very bottom, lumbar. So, but if it's a cranial, what type of nerves do you have in the cranium? You have cranial nerves. That's why you can see right here that the parasympathetic components of the nerve are going to be part of the cranial nerves. So what cranial nerves are going to have a parasympathetic piece, a parasympathetic component? It's going to be oculomotor, which is cranial nerve number 3, facial nerve, cranial nerve number 7, glossopharyngeal, cranial nerve number 9, and vagus, cranial nerve number 10. And you can see the vagus, as you know, it goes all the way down in order to innervate all these multiple different organs that we have. And those are going to be part of the parasympathetic nervous system. So if you scroll down, right here you're going to see in there the cranial nerves, oculomotor, facial, glossopharyngeal, and vagus, that they are going to have a parasympathetic control of the nervous system. If you scroll down, you can see here differences between sympathetic and parasympathetic, right? We said origin is thoracolumbar, parasympathetic is cranial. Fiber length, we say short if it's preganglionic, the case of sympathetic, but long if it's preganglionic and parasympathetic. So those are the differences basically that I show you in those figures. The enteric nervous system, in some books it says that the nervous system for the intestines, for example, is a separate group of nerves. However, in some other books it says that it's not, that it's actually part of the autonomic nervous system, so it's not very clear. If you scroll down, this is it for this part. Okay, the next topic is autonomic effects on target organs. We need to talk about neurotransmitters. So if you're looking here, remember this is preganglionic, you have acetylcholine. Postganglionic, acetylcholine. If you look at this other one, you can see acetylcholine preganglionic. Let's skip this for 1 second. If you scroll up again, you can see here for the parasympathetic, acetylcholine, preganglionic, acetylcholine, postganglionic. So then, which one is the most common neurotransmitter that you're going to have in the autonomic nervous system? Acetylcholine, in probably 80% of the cases. The other one, as you can see right here, is norepinephrine. If you get a question about neurotransmitters in the case of the autonomic nervous system, and you don't remember exactly the answer, then you should pick acetylcholine because it's the most common one. As you can see, it's everywhere. In the neuromuscular junction, you have also acetylcholine. So which ones are the receptors? The receptors for acetylcholine are going to be muscarinic and nicotinic receptors. And in the case of norepinephrine, the receptors are going to be alpha and beta receptors, as you can see down there. Okay, let's keep scrolling down. And right here you have the effects in the organs. In the case of the heart, for example, the parasympathetic slows down your heart, and the sympathetic speeds up your heart. So most of the time, the sympathetic is going to make things faster, and the parasympathetic is going to make things go slower. So in some other cases, it's not going to be true. It's going to be the other way around. As long as you know that parasympathetic most of the time slows down and sympathetic speeds up things, that should be okay, at least for my exam. So if we keep scrolling down, dual innervation. Some organs need the sympathetic and the parasympathetic in order to activate or make the organ work. So in this case, if you see this is the pupil, the parasympathetic is going to produce pupil constriction. And in the case of the sympathetic, it's going to dilate your pupil. So the pupils need the two types of autonomic nervous system, parasympathetic and sympathetic, in order to make it work. But there are some cases in which, as you can see here, control without dual innervation. In this case, is basically one of them. Most of the time, this is going to be the sympathetic. So you have right here the sympathetic nervous system. As you can see here, sympathetic fibers, that is constantly making this blood vessel smaller. When you want to dilate this, the stimulus is less. You see here the stimulus is more, so this is always constricted. So when you want to dilate, the stimulus is less, and the blood vessel is going to dilate, as you can see right here. So if we just keep scrolling down, that's it for this part. Okay, the next topic is central control of the autonomic function. Central control refers to your brain. As you know, your brain controls everything in your body. So we cannot separate the autonomic nervous system, even though we cannot control it voluntarily, but the brain still has control over that. For example, when you are in love, your blood pressure increases, your heart rate goes faster. So that is because your brain is going to make these things happen with the autonomic nervous system, but you don't have control over it. Same thing happens when your high blood pressure goes up, or when you are scared of something, your heart rate goes faster, you don't think about it, but your brain is going to do that. So that is, for example, in the case of the cerebral cortex. So the cerebral cortex not only does that, other areas in your body do the same thing as well, such as your hypothalamus, your midbrain, your brainstem, and your spinal cord as well. And that's about it for this part.